Okay, so today we will talk about probability. Okay, probability is just a percentage, or you can say is just a possibility of happening some event. Like if you are tossing a coin, so it can have two outcomes. It can be head or it can be tail. If you are throwing a dice, how many outcomes are possible? Moksha, if you are throwing a dice, how many outcomes are possible? Six. Okay, 1, 2, 3, 4, 5, 6. 6 numbers are there.
6.
Yeah, so totally 6 outcomes are possible. Okay. So
Yes, sir.
outcomes and sample space. So random experiment means if you are doing a thing, if you are tossing a coin, if you are throwing a dice, okay, you are just selecting one card from the 52 cards, or from 16 cards, 17 cards. Okay, you are just selecting some balls from a bag. So these are called as random experiments. Okay, and outcomes
Yes, sir.
outcomes are the things which are happening. So these are said to be the outcomes. Okay, and sample space means the possible outcomes.
Yes, sir.
All the possible outcomes are coming under sample space. Like if you are tossing a coin, so there are two possible outcomes, that is head and tail. So this is said to be the sample space. Got it?
Yes, sir.
Okay. If you are throwing a dice, so sample outcome 1, 2, 3, 4, 5, 6. These may be the sample outcomes. Okay. So all possibilities are said to be sample outcomes. Got it? Like two coins are tossed once, find a sample space. So sample space is head and tail. Okay. Like if you are tossing two coins, so what are the sample space? Like we drawn already the tree diagram in permutation and combinations. So if you are tossing two coins simultaneously, so if one coin is head, there may be two possibilities, head and tail, isn't it? So this is possibility of single experiment, single throw. If you are tossing another coin, so it may have head or tail, or it may have head or tail. So how many total outcomes? Head, it can be. Okay. Head, tail, it can be.
Tail, and head,
Tail, head, and tail. So how many total outcomes? So the entire one is said to be the sample space. Got it?
Yes, sir.
Okay. So if you are throwing a dice, so there are 6 outcomes. If you are throwing two dice together, so there are how many outcomes? 6 into 6. 6 into 6 outcomes will be there. Like dice will have 1, 2, 3, 4, 5 and 6, and 1, 2, 3, 4, 5 and 6. So it may be 1. So the possible outcome is 1, 1. Okay, 1, 2. It may be 2, 3, 4, 5, 6. Isn't it? It may also be 1, 2, 3, 4, 5, 6.
Yes,
So the possible outcomes are 1, 1, 1 with 1, and 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, like this. Okay. And another one will be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. So like that, it will continue, and it will be at last 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So how many total outcomes? How many elements are there in sample space? That will be 6 into 6, that is 36, isn't it? Getting
Yes,
it,
sir.
Moksha?
Yes, sir. Yes, sir.
Okay. So the outcomes of this experiment are ordered pair of head and tail. For the sake of simplicity, the commas are omitted from the ordered pair. Okay. So now example 2, find the sample space associated with the experiment of rolling a pair of dice. So I already told you, rolling a pair of dice, that will give
Yes,
you
sir.
6,
Was
6, 6, 6 into 6, that is 36 sample spaces like this. Okay. Now just do example 3.
yes, sir.
Example 3, just do it.
Hmm.
So in this question, boy has a 1 rupee coin, a 2 rupee coin and 5 rupee coin in his pocket. He takes out 2 coins out of his pocket, one after the other. The person is noting down the number of accidents along a busy highway during a year. Okay. Is it the entire? Yeah.
Sir, will it be like if we take Q, if we take it as like, for example, boys like ABC, right?
Yeah, let it be 1 rupee, 2 rupee or 5 rupee coin. It will have head and tail, head and tail, head and tail. Okay.
Yes, sir. It'll be one,
Yeah.
2, 1, 3.
He is.
Sorry, 1, 2, 1, 5. 2, 1, 2, 5, and 5, 1, 5, 2.
Yes. Okay. So a person is noting down the number of accidents along a busy highway during a year. Person is noting down the number of experiment along a busy highway during a year.
Sir, your voice is like it's lagging a little bit, sir.
Okay. So let Q denote 1 rupee coin, H denote 2 rupee coin and R denote 5 rupee coin. The first coin he takes out of his pocket may be one of 3 coins, that is Q, H or R. Okay, there are 3
It
possibilities.
can be as many number of accidents, right, sir? So infinity.
Okay. Corresponding to Q, the second row may be H or R. So the result of 2 row may be QH, QR, similarly corresponding to the second. Okay, therefore the outcomes may be, yeah. So the outcomes may be RH or RQ, yeah. So these are simple, first one is simple one. So these total outcomes will be QH, QR, HQ, HR, RH and RQ. Okay. So the number of accident along a busy highway during the year of observation can be either 0 or 1 or 2 or some other positive integers. Okay. So thus a sample space associated with this experiment will be a 0, 1, 2 up to infinity it will go, isn't it?
Yes, sir.
Okay, now do example 4. Do example 4.
Stars. Sir, will it be H blue ball 1, H blue ball 2, H blue ball 3, and HW, sorry, I mean like H white 1, H white 2, H white 3, H white 4, and then for tail it will be T1, T2, T3, T4, T6.
A coin is
T5.
tossed. If it shows head, we draw a ball from a bag consisting of 3 blue and 4 white ball. If it is shows tail, we throw a die. Describe a sample space. So if it is head, so what we are doing? We are just taking 3 blue and 4 white balls. So it may be blue 1, blue 2 and blue 3. Okay, 4 white balls, so white 1, white 2, white 3 and white 4. So that must be the sample space. Okay, HB1, HB2, HB3, HW1, HW2, HW3 and HW4. Now if it shows tail, we throw a die. So if it is showing tail, so we are throwing a die. So that will be the sample space that time, isn't it? So T1, T2, T3, T4,
Yes.
T5, T6. So that will be the sample space. Got it?
Yes, sir.
Okay. So if you combine all these things, so combining all these things together, that will become your sample space. Okay.
Okay.
Now do example 5.
Mm.
Consider the experiment in which a coin is tossed repeatedly until a head comes up. Describe the sample space. That means there is
So
no.
shouldn't it be like if the first time you get in the first time only if you get hit then it will be 1. If you get it after 1 try then it will be TH. And
Yes,
then
yes.
after 2 tries it will be TTH and
Yeah.
on so.
Yes, yes, yes. So it will go up to infinity. Okay.
Yes, sir. Sir, I'll just close my door back.
Okay, please, please,
Sorry.
please.
Sorry, sir.
Okay, no issues. Okay. Now do exercise 16.1. In this exercise you need to find it only the sample space. A coin is tossed 3 times. So what will be the sample space? If you toss a coin 3 times.
Coin is tossed 3 times. Okay. So is it 8 outcomes?
Yeah.
Um,
Yeah, it will be 8 outcomes, but what outcomes will it be?
okay, okay. HHH, THH, HTH, HHT, TTT, HTT, THT, and TTH.
Yes. So it will be easy if you draw the diagram like this. Uh, just you are tossing 2 coins. So HT will be the possibilities. After that, again HT, again HT. Now again HT, again HT, again HT, and for this again HT. Okay, so HHH, HTT, HTH, HTT, THH, THT, TTH, and TTT. So these will be the total possible outcomes. Okay.
Yes, sir.
Okay, now die is thrown 2 times, so we already did it, isn't it?
Yes, sir.
Okay.
And then a die is thrown 2 times. So, like we said earlier,
Yeah, we
that
said
is
it. We said it earlier. Coin is tossed 4 times. So that is also
4
easy.
times 16.
Yeah, 16 outcomes will be there. The coin is tossed and a die is thrown. So you are
Okay.
tossing a coin
That
and
will be H and 6. H 6 times and T 6 times. So 12.
yeah, H with 1 2 3 4 5 6, T with 1 2 3 4 5 6. So there will be total 12 outcomes. Okay.
Yes.
And fifth one, a coin is tossed and then a die is rolled only in case a head is shown on the coin. Just do fifth one.
Coin tossed and then a die is rolled only in the case a head is shown on the coin. So isn't it just
Yeah.
it
If
will be H 6 times and only a T.
T,
So 7. 7.
yeah, head with 1 2 3 4 5
It will
6.
be H. It will go on from H to H6, but as soon as the tail comes, it stops, right?
Yeah, you're right. Okay, now do sixth one.
2 boys, 2 girls, and X. 1 boy and 3 girls and room X. it like for room X, so there'll be X with the first boy and then X with the second boy, and
Yeah.
vice versa with the girls.
Yeah.
And in room Y, it'll be Y with the first boy and Y with the three girls.
No, 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 no. Two boys and two girls are in room X, and one boy and three girls are in room Y.
Okay.
So boy three with
Okay, okay. Okay, sir, I got it. Yes, sir, yes, sir. Boy 3 is in the in room Y, right?
yeah. Okay.
So basically, then the girls will also be girl 3 onwards.
Yeah. Girl 3, 4, 5.
Sir.
Okay.
Yes, sir. Yes, sir.
Now seventh.
Mm, One die of red color, one of white color, one of blue color, placed in a bag. So is it like R1 to if we take like the red color, white color, and blue color as like R, W, and D,
Yes.
then be R into it's like total 18 outcomes, right?
Yeah.
Six,
R
six,
R with 1 to 6.
six
White
each.
white with 1 to 6 and blue with 1 to 6.
Yes, sir.
Okay. Very good.
Yes, sir.
Okay. Now we'll do eighth one. Okay. It has two parts. Just finish it first. Then we'll go to second.
Mm, so it's like GG, BB, GB, BG.
Yes, right. Because both
And
of
then
them
the second one?
both of them could be boy boy, boy girl, girl boy, and girl girl. Second one is asking you what is the sample space if you are interested in the number of girls in the family.
There'll be 2, 1, or 0.
Yeah. There may be two girls, there may be one girls, there may be no girl. Okay? Now do ninth one. So I think almost clear about sample space. How to form
Yes,
it.
sir. Mm, 1 red and 3 white. So they said identical white balls, right? So
Identical.
drawing, like if we draw like one of the white balls also, it's like it's the same, right?
Yeah.
So then it will be W if it's like white balls, two white balls at the same time, or two, and then WR and RW.
Okay, right.
There'll be no red together because there's only one.
Yeah, right. Okay, now go for 10th one.
Mm, fine. Mm. So is it like when there's like head, there'll be head, tail, and tail, head. Sorry, head, tail, and hedge.
Okay.
And then when there's tail, then it's like T to 6.
Yeah, 1 to 6 it is. Okay. Go for 11th.
Yes. Yes. Three balls are circular a lot. Mm. So the sample space will be, wait, three balls. So is it 8?
Yeah, 8 it will be.
So all defective and all non-defective, and then defective, defective, non-defective, non-defective, non.
Okay, you can write it DD.
Like so on. It's like that path.
Yes,
Yes, sir. Yes,
yes,
sir.
yes.
DDN, DND, NDD, DNN,
Okay.
and then
Okay, now go for 12th one.
D.
Go for 12th one now.
Yes, sir. Yes, sir. Coin starts with the outcome is a head, a die is thrown. So we have to eliminate like we have to take only three and then like first then because we have to take only even numbers, right?
The coin is tossed if the outcome is head.
We have to
So,
take only 2, 4, and 6.
yeah. A die is thrown.
Then we have to
If the
take.
die shows up an even number, the die is thrown again. What is the sample space for the experiment? So, first of all, you need to have
So
with.
it should be first. First we have to take the odd number with the head. Then H1, H2. Sorry, H1, H3, H5, and then H2 and H2 like that up to H26,
No,
and
no,
then
no.
H4 one
See,
up to
see.
H6, and then H6 one up to H6,
It is
and
good.
then T.
It is good if you draw the diagram. Coin is tossed. So, if coin is tossed, that means head and tail. Okay. if the outcome is head, so with head a die is thrown. So with head you are getting 1, 2, 3, 4, 5 and 6. Okay. If the die shows up an even number, so with even number 2, 4 and 6. If the die shows up an even number, the die is thrown again. Now it can be again with 2, it can be 1, 2, 3, 4, 5, 6, isn't it? With 4 it can be 1, 2, 3, 4, 5, 6. With 6 also it can be 1, 2, 3, 4, 5, 6. So like this you need to make sample space. What is sample space? Yeah, so that will be head 1, okay.
Yes, sir.
And head 3, head 5, head 2, 1, head 2,
Head
2.
3, head 5, and then H2 1
Yeah,
till H2 6, and then H4 1 up
and the T will also be
to
counted.
H4 6, and H6 1 up to H6 6, and then T.
Yeah, alone T will be considered as as the member of sample space. Okay. Now do 13th. I hope you're getting concept very clear.
Yes, sir.
Your camera is switch off.
Sir, I'm doing the second one. What's it?
Your camera is switch off.
Yeah. So now?
Now, no.
1 second. Sir, can you see?
Yeah, please. Yes. Now it is visible.
Sir, my webcam, I need to buy another one, sir. I'll buy a new one. It's quite old. Since COVID, I had it.
Okay.
They said no replacement. It's like that permutation combinations first. If 4 is taken, then 1 is fixed, so 3.
Yes.
So 4 into 3, 12 comes.
ठीक है.
Next one consists of a die and then tossing the coin once if the number on the die is even, number on the die is odd, then comes twice twice. Write this on the page. Write this experiment. So, if like the number is even, then is it like 2 2 2 2 2h 4h 6 h and then 2t, 4t, 6t.
Yeah. Right. Now second part.
And if it's like odd, then 1hh, 3hh, 5hh.
Okay.
And then 1ht, 3ht, 5ht, then 1th, 3th, 5th, and 1tt, 3tt, 5t.
Okay. So total how much it should be?
Then overall, all added is the final sample space.
Okay. Yeah. Go for the next one.
If the coin shows tail, we draw a ball. Of the contains 2 red and 3 black balls. If it shows head, we throw die from the sample space for this experiment. We take red balls as R1, R2. Black balls V1, V2, V3. So if it's tail, then it's TR1, TR2, TB1, TB2, TB3.
Okay.
And for H, it will be H1 to 6.
Okay, good. Now the last one, 16th.
Dice thrown repeatedly until the 6 comes up. Until 6 comes up. It's basically 1, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, right?
Yes.
Like before.
And initially it can come 6 alone in the first attempt.
Okay, yes.
Okay.
Oh wait, no, it will be 6, 1, 6, then 2, 6, then 3, 6, then 4, 6, then 5, 6, and then we have to do 1, 1, 6, 1, 2, 6.
Yes.
It's like that, right?
Yeah. Okay. Okay, so like this it has been completed. Now we'll see event. So till now we have studied about random experiment and sample space associated with an experiment. The sample space serves as a universal set. So sample space basically is a universal set of all questions concerned with the experiment. Got it? So sample space is the total outcomes. Got it?
Yes, sir.
And event means your occurrence of now suppose that we are interested in those outcomes which corresponds to the occurrence of exactly one head. So one head can be with, if you are tossing 2 coins, so one head can be HT and TH, only one. Okay. So we find that HT and TH are the only elements of S corresponding to the occurrence of this happening. So these 2 elements form the set E. So we now set E is a subset of the sample space. Similarly, we find the following correspondence between events and subsets. So this is an event. Okay?
Yes, sir.
Got it?
Yes, sir. Yes, sir.
So description of number of events corresponding subsets of S. So number of tails is exactly 2. So that is only one possible outcome, TT. Number of tails is at least 1. At least 1 means one tail is must. So HT, TH and TT. So out of sample spaces we can have following subsets. So like number of tails is exactly 2, there are only one member. Number of tails is at least 1, so there will be 3 possibilities. Number of heads is at most 1. At most means maximum head can be 1 only. Okay? So HT, TH and TT. Number of head is at most 1. So HT, TH and TT. second toss is not had. So not had, second toss is not had means HTTT. Second one will not be had. Okay. Number of tails is at most 2. At most 2 means maximum tails can be 2. So lesser than 2 is also possible.
Yes.
So no tail, one tail and 2 tails. Okay. Number of tails is more than 2. More than 2 tails. So if you are tossing 2 coins only, so number of tails cannot be more than 2. So that will be 5. 5 is a null set. There will not be any element. Okay. So any subset of your sample space is called an event. Okay.
Yes, sir.
Now occurrence of types of event, there may be 2 type of events are possible. One is impossible and sure event. Impossible means like sun rising from west. So that is an impossible event.
Yes, sir.
Isn't it? So it's, and sure event, sun rises from the east. So that is a sure event. Okay.
Yes, sir.
So simple event, if it is having only one sample point of a sample space, it is called a simple event. Okay. So in a simple space containing n distinct elements, there are exactly n simple events. So these are, now compound event, if an event has more than one sample point, it is called a compound event. For example, exactly one had appeared. So exactly one had appeared means
There can be only one head.
yeah. So for example, in the experiment tossing a coin thrice, the event exactly one head appeared. So exactly one head appeared will contain more than one events, isn't it?
Yes. Yes, sir.
So at least one head, so it will also have more than one event. So it is called as compound events. Now algebra of events. So rules of set theory will be applicable in case of algebra of events. Complementary events.
Like
Another event is
it
called a
may be
complementary event
the
to
same
a,
sample space for two different conditions.
yeah, in case of set theory, what was complement of any set?
Everything that's not that particular
Yeah,
problem.
anything which is not in sample space. Everything which is not in sample space from that set is called as complementary event. Okay. So for every event A, there corresponds another event is called a complementary event to A. It is also called the event not A. It is not A. Okay. So for example, take the experiment of tossing 3 coins and isolated sample space is this one. So this is an event A. B the event only one tail appears. So one tail appears. Clearly for the outcome HT the event A has not occurred, but we may say that the event not A has occurred. Thus with every outcome which is not in A, we say that not A occurs. Okay. So basically it is complementary means other than this event. Other than this event from the sample space, everything is complementary. Okay, basically we'll S minus A. S minus A will be the complementary of event A. So you just need to subtract event from sample spaces. Okay.
Yes,
The event A or B means it is union, combining A and B together. Okay.
it can be both.
Yeah.
Yes, sir.
And event A and B, that both events will be performing simultaneously. Okay. So that is called as A and B. So that is basically intersection. The event A but not B. A but not B is A minus B. A is there but B is not there. So that will be A minus B. Okay. Now just do example 6.
Yes, sir.
So these all rules are basically from set theory.
Yes, sir.
Your concepts of set theory are clear or not?
Yes, sir.
Okay. Then only it will look you easy.
Yes, sir. Mm. So for A or B, it's 1, 2, 3, and 5.
What is A event? Consider the experiment of rolling a die. Let A be the event getting a prime number. So set A will be
Sir,
2, 3, 5 prime number,
yes, sir. Yes, sir.
and set B be the event getting an odd number. B will be 1, 3, 5,
Yes, sir.
and your sample space will be 1, 2, 3, 4, 5, 6.
1, 2, 3, 5. Right.
1, 2, 3, 4, 5, 6 sample space.
Okay, yes, sir. Yes, sir. उसमें if we take A or B, there will be 1, 2, 3, and 4.
Yeah. So A or B, 1, 2, 3, 5.
Then
A and B,
A and B will be 3 and 5.
yes. A but not B.
A but not B is wait. A but not B 2,
2. Not A.
and then not A is 1, 1.
What is A? A is 3, 5,
A
6.
is 1, 3.
A is 2, 3, 5.
Yes, sir.
So not A means other than this. So 1, 4 and 6.
Okay. Yes, sir. Yes, sir. My bad.
Got it?
Yes, sir.
Okay, now we'll see mutually exclusive events.
Yes, sir.
See, if two events are not depending upon each other, so these are said to be mutually exclusive events. Okay. So let us say an example, if you are rolling a die, sample space B 1, 2, 3, 4, 5, 6, consider event A, an odd number appears, and B, an even number appears. So odd number and even number, both are different things. They will not be there will not be any common element in between. Okay. So if A is a set of odd numbers, so 1, 3, 5 will be there. If it is in set of even numbers, so that will be 2, 4, 6. So is there any common thing in between these two events? No. So these are said to be the mutually exclusive events. Okay.
Yes, sir.
So like if we have taken 1, 3, 5 and 1, 2, 3, there are two sets. So there 3 is common in set A and set B. So they are not mutually exclusive events. Okay. There should not be any common. Now exhaustive events. So exhaustive event, consider the experiment of throwing a die. We have this will be a sample space. Let us define the following events. A, number less than 4. Number less than 4 is 1, 2, 3. So these are 3 sets. We observe that A union B union C. So that contains, if you join all these sets, so that will make sample space. So these are said to be the exhaustive events. Okay. Like in previous case, it was set A was the set of even numbers, set B was the set of odd numbers. So if you make union of these two, you will get sample space. Okay, so in that case, both of the event A and B will be your exhaustive events. Okay.
Yes, sir.
And in the previous example also, they were mutually exclusive and exhaustive also. Got it?
Yes, sir.
Now do this last example for the day.
Two dice are thrown. The sum of the numbers. So you have to take the 36 outcomes, right?
Yes.
And then sum is even. Then the sum has to be 2, 4, 6, 8, 10 or 12.
Yes. Yes.
Then 1, 1, 1, 3, 1, 5, 2, 2, 4, 2, 6, 3, 1, 3, 3, 2, 5, 4, 2, 4, 5, 2, 6, 5, 1, 5, 3, 1, 5. So it's like 1, 3, 1, 5, 2, 2, 2,
Yes.
4, 2,
Yes.
6,
Yes.
3, 1,
Yes.
3, 2, 3, 5
Yes. It will be like
numbers.
that. Yeah, it will be like that.
Then sum is multiple of 3.
Okay. Okay. Okay.
Then it has to be 9, 3, 9, 6 or 12.
Yes.
1, 2, 2, 1, 1, 5, 5, 1, 3, 6, 3, 6, 6, 3, 2, 4, 4, 2, 4, 5, 5, 4 and 6, 6.
Okay.
Less than 4, less than 4. Then it has to be 1, 2 or 4. Then 1, 1, 2, 1, 1, 2.
Okay.
Then sum is greater than 11. Sum has to be 12. Then 6, 6. Only 1.
Yeah. Right.
Oh, they asked what are mutually exclusive events.
Yeah.
There shouldn't be any common element, right?
Yes.
C and D.
C and D. Yeah.
Because it's 1, 1, 2, 1 and 1, 2 and then D is 6, 6.
Okay. Is there any other?
No, sir, I don't think so.
Okay. So only C and D are mutually exclusive event because there is nothing common in their in that sets. Okay.
Yes, sir.
So uh, go through the remaining examples and the exercise. Okay. Only one example is left. So exercise 16.2 will be your homework, and just do it.
Will you be taking classes every day from now on? Can you take that? Because 19th is my exam. It's like 4 days.
Yeah. So would you like to have tomorrow also?
Yes, sir. And can you send like papers and all? I'll solve at home.
Okay. Just tell me which paper you required.
Sir,
Okay.
any paper, sir. Like I need to get above 70 out of 80 for this exam.
Okay. So you want full paper?
Yes, sir. All like all. I mean,
Whole
you
chapter.
know my syllabus, right?
All
You
chapters.
obviously. Yes, sir. Just send me a paper with all chapters. I'll just check which chapters are not included, and I'll do the questions from only the chapters I have.
Okay. So I'll send you the complete
Send me
paper.
multiple papers, sir. Send me like even
Yeah,
if it's like 10 papers, I'll do.
yeah, it will be, yeah, I'll send you 10 papers, no issues.
Okay, sir.
It will be according to your blueprint. Okay, just
Yes, sir.
send me your blueprint. So
Sir,
that,
our school didn't give us any kind of blueprint.
okay, so
It'll be according to CBSE standards only. That's
okay,
what I
okay,
heard.
okay, okay, okay. So I'll make sure that it is adhering with blueprint
Oh, sir,
only.
we have assertion reasoning also. We have like
Okay,
3 books.
okay. I'll prepare it accordingly.
Okay, sir.
Okay, I'll send it to you today. I think after 8 o'clock. I'll send you.